I'm Cameron Swords, this is Spencer Bauman. We collectively had a really terrible idea, so we thought we'd get up and share it with everyone. Background. There's this thing called RPython. It's for making really fast JITs. It does meta tracing. If you stare at Haskell the right way while it's running, it sort of looks like this dynamic language that you're doing graph reductions over in the heap. So there's actually been some previous work in re-implementing Haskell to try to use RPython and make it fast. It turns out that both of these approaches have tried to interpret core. They both beat GHCI and they both lost very badly to GHC. So with that in mind, we have this question. Is it possible to efficiently JIT a lazy language like Haskell? So Spencer will be giving a talk tomorrow about how this actually worked super well for RPython, or for Racket. And it did that by just grabbing a CEK machine and saying, well, the CEK machine is simple, so we can make it go fast. So what would that look like for GHC? Well, here's a classic STG machine, formal semantics. If we just take that config and we actually just start running it, maybe we can make it fast by using some of the same things that Picket does. Would you like to tell them what Picket does?
Well, thank you for that introduction. So, yeah, probably the first order of business, you need to identify the right unit of compilation for a tracing JIT compiler, which is not like your standard per method or function JIT. You need to identify loops in your program. Picket includes this method based on the call graph, which we think would be very applicable also to while running the STG machine. There's also potential for exposing other optimizations from the abstract machine by doing some kind of runtime analysis rather than relying heavily on static optimizations, and really just exploring what trace compilation can get us where that we can't get during at compile time. And so there's probably a lot of things that really need cleaned up in the implementation. It was made for a class in a couple days, so it really needs to be refactored and cleaned up. We also need to support more of the whole STG specification, and it would be really nice to have a front-end parser, because right now we're just manually writing AST specifications in Python, and this makes it very difficult to test real-world examples. So, thank you. We haven't talked to him, though he made use of kind of this custom interpreter that built on top of LuaJIT, and we're taking a slightly different approach in that we have a much higher level specification of the interpreter, and we're relying more on the JIT compiler to eliminate all of those costs.